You know, I almost forgot to talk about different factors that affect the kinetics of a reaction. My apologies. So there are kind of four basic factors that will affect how fast a reaction occurs, essentially. So if we're talking about, if we're looking at the concentration of our products, of our reactants, it can be the products as well, actually, but generally of our reactants, this is going to affect how fast the reaction occurs. Generally speaking, if we've got more reactants, we will have a faster rate of conversion into products. But like I did mention, this can actually be conversely true. Sometimes if you have more products, it will flip the direction of the reaction and you'll end up with a decomposition or a different, the reverse reaction essentially. But the concentration of the reactants matters. Generally speaking, higher concentration is going to equal a faster rate of reaction. Temperature, this shouldn't be too surprising, but at a higher temperature, generally, our reactions will occur faster. Why do you think that is? Hopefully you're saying because at higher temperatures, molecules have more energy, which means they're moving around more quickly, and they have a higher chance of running into each other. And later in this unit, you're going to talk about how it's not just the speed at which molecules run into each other, but also it's important for them to have more collisions because molecules will have to hit each other in the right way. You can't just bounce any two molecules off each other and have some magic reaction occur. They need to be the right molecules with the right amount of energy hitting at the right, kind of in the right way. So temperature increases those collisions, which will generally increase the rate of reaction. If we're talking at a macroscopic scale, surface area is really important. If you have a big chunk of your reactant and you put it in, for example, some sort of solution, there's reduced surface area for that solution to access. So there's this whole large concentration, this whole large mass of those molecules that you want to react, but some of them are only able to contact similar molecules. They're not able to contact the other reactants to form product. But if you have that same lump of reactant that's broken up into, for example, a powder, you have a much higher surface area, and so you've got much more available molecules. Another thing that so going back to surface area, generally if you have a higher surface area, you're going to have a higher rate of reaction. Catalysts can also be something that are, generally speaking, again, not always, and this is one where I think we'll talk in the future more about how some catalysts may not increase reaction rates, but generally speaking, catalysts increase reaction rates by lowering the energy it takes to complete the reaction. Catalysts act as kind of, a helper to lower that reaction, the required reaction energy. Some other things that may influence kinetics of a reaction could be external environmental pressures. Things about if you're running a reaction in a solution, that often has to do with concentration or temperature. If you're running in a reaction under pressure, that can certainly influence how much pressure can influence the rate of reaction as well. So it's important to think about all the factors that can affect the kinetics of a reaction, because if you're conducting your own research or if you're asking questions, these are all factors that you need to consider for your reactions.